So now we move on to another kind of differential equation we're going to solve. They're called linear differential equations. So this is what it'll look like. So you'll have the derivative, you'll have some term with perhaps some x's in front of it, but a y term that's added or subtracted, and then some other x term. So first you must get, in order to solve these kind of equations, so you're going to have three terms minimum, you must get this into what's called the standard form. So it must be in this form. So a 1 in front of the y prime, and on the same side the y prime is on, then you have your p of xy, and then your other term with just the x's on the right hand side. Okay, once you get it in this form, then you make what's called an integrating factor. So it's a contrived thing that's going to help you do something. So let me talk about what this integrating factor is. So the integrating factor we're going to call I is going to be e to the integral, yes, there's an integral in the exponent, integral of p of x dx. So we're going to take the integral of the term that's in front of the y. If there's a negative there, we have to include that. That's a big deal. I'll show you examples in a second. Okay, so we're going to find out what this is. We'll do this integral, so we'll get this e term, or maybe something will cancel, but we'll get this I term. Okay, so what we do is we multiply both sides by this integrating factor. The reason we're doing this is we're making product rule happen on the left-hand side so that the left-hand side will turn into the derivative of your integrating factor times y. Then we'll be able to integrate both sides. Let's do this. Okay, this is not in standard form, so let's fix it. So y prime plus 3x squared y equals 6x squared. So now it is in the standard form. So now I'm going to make my integrating factor. So it's e to the integral of this here. So positive 3x squared. So I know the integral of 3x squared will be x cubed over 3. The 3's will cancel, and I'm not going to worry about the plus c. So I get e to the x cubed. So that's my integrating factor. So I multiply both sides by e to the x cubed. So e to the x cubed y prime plus 3x squared e to the x cubed y, 6x squared e to the x cubed. Okay, so the reason I did this is to make product rule happen on the left-hand side. So this should be e to the x cubed times y. So check it to make sure. So if I was to take the derivative of this and this, so let's go backwards. So it's first d second plus second d first. So how do you take the derivative of e to the x cubed? E to the x cubed times the derivative of x cubed, which is 3x squared. So if it doesn't work, you made a mistake in making your integrating factor. So you can always check it. The derivative this way, right? Doing the product rule should give you these two terms. So this side carries along. So now I'm ready to integrate. So when I take, let me just use a different color. So when I take the integral dx of both sides, this side here, the integral and the derivative cancel. So I'm just left with e to the x cubed times y. This side here is an adventure. You never know what's going to happen. So I'm looking at this and I see easy u, right? Don't go for parts first. Always think about, can I do it? The next stage is, can I do easy U substitution? So let's see. I think if I multiply both sides by 2, right? So I get 2 du and e to the u. So I'm going slow to make sure I don't make any mistakes. So integral of e to the u is e to the u, put the x's back in, and then add a plus c, correct? You have to add the plus c right after you finish integrating. Now solve for y. So solving for y, I get 2e to the x cubed plus c divided by e to the x cubed. So you could separate this. So it would be y equal this over this, which would give me 2, right? Because the e to the x cubed would cancels, plus c over e to the x cubed. So c divided by a function is not c, correct? So you could rewrite this as this, right? Either way, this is correct or this is correct. Okay, so here is another one. Let's do one more. Let's stop it here.